Swayam Prabha. Digital India. Educated India.
In order to do this, first let's look at the relationship between charges and fields and currents and voltages. Okay, so what is an electric current? Electric current, as you well know, is basically the rate of flow of charges. That is, if you have a certain surface and some charges are moving in this direction. Okay, so let's say these are some positive charges, and the rate of flow of charges, which is basically dq by dt across a certain surface, is the current through the surface. Okay, so if you have, let's say, a 1 coulomb charge, that is plus 1 coulomb charge, and that happens to cross this surface in 1 second, that is, over 1 second a total of 1 coulomb of charge crosses a certain surface, then the current will be the rate of change of charge, which is 1 coulomb per second, which is given the unit of 1 ampere. Okay. Now you also very likely know this, for historical reasons current is considered to be the flow of positive charges, because all these things were done before atomic structure of matter was discovered. So even though we know now that it's the electrons that are moving, there are no positive charges that are moving. When we say a certain positive charge is moving from left to right, it's really the electron that is moving from right to left, at least as far as electrical circuits are concerned. So even though we know that is true, we still define the current as rate of flow of positive charges, okay, because that's the convention. So you should, if you want to get a physical picture of this, you should imagine electrons moving in the opposite direction. Now this is a very general definition of current, and depending on how charges are moving across the surface, you can compute the current by looking at how much charge is moving across the surface in 1 second. Now, in case of electrical circuits, it turns out that we will have certain conductors which are you can think of them as wires, okay, or you could have some electrical elements. Now it turns out that the charges move only through these wires, or through the wires connected to the element and through the element itself, okay. And we'll concern ourselves with the total charge that is moving through the wire, okay, and we won't worry about exactly how it is distributed across the surface of the wire. Now there will be some advanced circuits in which this may be of concern, but most of the circuits can be dealt with by completely ignoring how the charges are distributed across the surface of the wire through which the charges are flowing, and considering only the total charge flowing through the wire. So like I said earlier, if you ignore the spatial extents of the problem, spatial distribution of charges or fields, things become immensely simple compared to problems in electromagnetics. Okay, so the first thing is that we will only worry about the total amount of charge that is flowing through the wire, or basically the total current flowing through the wire. So that is one simplification. Now this is possible because we can have these wires and charges flow only through these wires, and the current or any charge flow outside the wires can be considered to be negligible. Okay, there are a lot of very useful contexts in which this assumption holds very well. So we can make this assumption safely. Okay. Let's say we have a wire and we have 1 coulomb per second of charge flowing in this direction. Okay. So what does this mean? This is 1 ampere current from A to B through the wire, which is exactly the same as saying minus 1 amp current from B to A through the wire. Now again, this is quite obvious, but the reason I am writing this is, as you solve for circuits, you will encounter both positive currents and negative currents. Okay, and you should become very comfortable dealing with either one of the polarities. Okay, so in any element, if you take 1 ampere of current in one direction, it's exactly equivalent to having minus 1 ampere of current in the opposite direction. Okay, so you shouldn't get uncomfortable with and confused with polarities of currents.